Hello and welcome to Module 7 of the Risk Assessment Short Course. In this module, we're going to talk about the third step in risk assessment, which is hazard characterization. So the learning objectives for this module are shown here. First, to understand what information a hazard characterization produces, and then to understand the source of information about dose response and the limitations of those different types of sources. So recall that in the first step of risk assessment, the hazard identification step, there's three different types of hazards. There's chemical, biological, and physical. So we don't talk a lot about physical in this course. Chemical and biological are really the most significant in terms of public health impact. And then we're really going to only focus on microbial from here on out. Human health impacts from chemical contaminants are most often about chronic exposure. So something that you have maybe a small dose or maybe a big dose, but it's something that happens over a long period of time, over days and days and months and years. And so you would need to have that exposure over time to estimate the potential risk, the potential negative health impacts that would result from that exposure. There are some chemicals that cause acute health impacts, but most of the chemicals that we worry about are the chronic exposure, and we're focused more on microbial risk assessment in Tartar and in these courses as well. But I just wanted to note that chemical risk assessment takes a slightly different approach in terms of hazard characterization. So when we were talking about biological contaminants, we're talking about acute exposure, so you can just be exposed once and get sick from it, and it's something that makes you sick right away. So it's easier to detect in terms of that causing the illness. So we talk about a dose per serving in terms of what we use to assess risk. So in the exposure assessment section before this, we talked about estimating the dose, estimating how much you're exposed to based on how much of the hazard is in the food, how much of the hazard you're consuming, multiply that out to get an estimate of what your dose is, or how much of the hazard you're being exposed to. And a few other things about differences between microbes and chemicals. As I mentioned, microbes can cause illness from a single exposure, whereas chemicals are typically from chronic exposure over time. There's also other dynamic issues that you take into account when you're estimating risk from microbial pathogens, which is that microbes grow, of course, they're alive, they're biological, so they can multiply in the host, they can multiply in the food. So this creates challenges when you're trying to estimate how much of the contaminant was consumed by the person, and then would the person end up getting sick, and if the hazard is multiplying in the person, obviously the dose is changing. You also have these complexities in terms of secondary spread, and you can have a wide range of health effects from microbial contamination. So all of these things about microbial contamination makes it much more challenging to be able to model and do these estimates for. So I wanted to note that here. So again, in these courses, we're just going to kind of touch on the high level of how these are done, but of course there's many, many other complexities that could be layered on to try to take into account all of these variables and all these things that are changing as you're estimating the risk. So hazard characterization is also could also be referred to as a dose response. You might have heard that term. So the idea is to provide a way of estimating the expected health impact from a certain dose. So we call these a dose response function. So you have a certain amount of dose, and then based on that dose, you have a certain amount of response. And these dose response relationships can be expressed in mathematical terms. So these are not things that you can develop on your own. These are things that would be pulled from the literature, from other research that has been conducted to determine what the different levels of exposure were to the people who became sick. And so you need to find a dose response curve in the laboratory for the specific pathogen that you're interested in, and use that to model your risk. So this dose response curve is really a mathematical description of the relationship between exposure or dose and the response. So these dose response relationships are are derived from studies that quantitatively characterize the association. So you really need to have studies that have information about how much the product was, how much the person was exposed to, and how much how much harm they ended up having at the end. So there are many challenges, as you can imagine, as I talked about all the difficulties of estimating exposure from microbiological pathogens. So kind of, the studies that were done, you're trying to understand the exposure versus the dose. So the exposure is how much the person took in. The dose is really how much their body experienced. As we talked about, that can change. The assessment of response, how is it measured? How much time, how long were the participants followed over time? Was it just they were followed over 10 days or 10 months or 10 years? Because we know that there can be, kind of more complications that come over time. So how was that response measured? And then which mathematical model was used to represent that fit? So again, exposure versus dose. Exposure is outside the body, kind of what's coming in, and then dose is inside the body. So depending on how the studies were done, they might be measured in different ways. So this adds uncertainty. So typically, we don't talk a lot about the difference between exposure and dose, but understanding it, especially in microbial pathogens, is an important part of being able to be confident that your dose response curve is valid. So again, a response could be a acute or immediate effect, or it could be something with delayed onset. As I mentioned, if you have a study that only follows people for a short amount of time after the study, then you might not have data on those longer term effects. And you also could have short-term illnesses, something that you get better from, or you could have a chronic illness that, once you have it, it really doesn't go away. So those are different kinds of responses that could be measured in these studies. So, as I hope you're starting to understand, there's many challenges to estimating these dose response curves for all the pathogens that we look at in the United States. There are dose response curves, but there's also always new research coming out that adds to our understanding of those. And so really knowing what the best models are out there for dose response is part of the work of doing good risk assessment modeling for food safety. There's many additional complications. There's genetic variations of the different pathogens. There's virulence factors that could be making things more or less hazardous, more or less harmful in terms of causing harm, in terms of causing some kind of health impact. There's different threshold levels. So it might be that some people are exposed to so much of a pathogen and they don't get sick, and then once it gets over that line, they get sick. Those might be different for different people. So that makes these kinds of estimates and modeling of dose response functions very challenging. And there's other factors that are true about the person, kind of other conditions they might have or other genetic factors they have that could also impact the health response. So you can imagine trying to incorporate all of these things into one study is very complicated, and it's really just important for you to understand when you're using a dose response function that was generated from a study. It's important for you to understand all of these different ways that add to the uncertainty in that estimate. And so we use the models that we have, but there is a lot of uncertainty in those estimates. And so finally, just the last slide to show you what we mean when we talk about dose response curve. So we have this dose on the x-axis, and then we have the percent of population sickened. You can use any kind of measure there in terms of response on the y-graph, and it shows you this S-curve, as we say. And so this would be based on a study that collected data on people or animals, if it was an animal study, that were exposed to this and kind of what kind of response they had. So based on the data, they would generate a curve like this, which could be then used in the risk assessment. So I hope this short review gave you a sense of what we mean when we talked about a hazard characterization, and that it really helps you understand the sources and also the limitations of dose response functions that are used in risk assessment.